So I'm doing a recording for the evaluation of antiseptics and disinfectants lab. Um, I've had a couple people that have emailed me. They seem to be confused about how to go about the lab, and there is cost for confusion. There's a little bit of lack of uniformity in how the dilutions of the different substances is carried out. And so I'm going to seek to explain that here and see if that helps. So I think where we're in trouble here is when we're talking about how to carry on our dilutions, okay? And we start here on page 8 with bleach, and then we go to Lysol, and then we go to isopropyl, and then we go to on and on and on. And it's a little bit sketchy on how the authors came up with this. So what I did in an effort to explain this is I made tables that organize the words into something that you can look at, and hopefully it'll make a little bit more sense. Okay, so this is what my little table looks like. So here's bleach. Let me see if I can make that a little bit bigger still. Okay, so here's bleach. And then I have one for Lysol, one for the hydrogen peroxide, and one for the isopropyl alcohol. And I just noticed that I didn't make a title for it, but that's easy enough to do. Merge cells. There we go. And then we'll put here isopropyl alcohol. Anyways, except for this title, I've uploaded this to the lab area so that you guys have access to it. And you can use it as a guide. Like I said, hopefully it helps. I'm trying. Okay. So let's start with bleach. All right. Instead of reading the protocol that they give you, let's take a look at this table and see if it doesn't help explain what we're doing a little bit better. Okay. So we're trying to come up with 3 concentrations of bleach. We need 3 Petri dishes. Okay. So we have 3 Petri dishes. There they are. And we're going to label them. And the author tells you to use that horrible grease pencil. I hate that grease pencil. Me, I like to use a Sharpie, thin tip Sharpie. Okay. So I'm going to go ahead and label this 1% bleach. 1% bleach. Then I'm going to label my second Petri dish 0.1%. And then label the third one 0.01%. And I typically tell you to do on the bottom of the Petri dish where the media is at, but these Petri dishes do not have media. And furthermore, what we're doing is not going to stay in the Petri dishes. It's an intermediary. When we're done, everything's going to go into tubes of nutrient broth. Okay. So what I did is I color coded this a little bit. Yellow is the first dish, which is my 1%. Boom, 1%. Green is my second dish, which is 0.1%. And blue is my third dish, which is my 0.01%. Okay, so there's my 3 dishes. Now, what am I going to do? I'm going to take my 10% bleach from the kit, okay, and in Petri dish number 1, the 1%, okay, the 1% Petri dish, I'm going to put 1 milliliter of 10% bleach and 9 milliliters of water for a total volume of 10 milliliters. When I do this, I have just diluted that 10% bleach into 1% bleach, which is what's supposed to be in the first Petri dish. Okay? Now, for those of you who care about the calculations, okay, I put them here. I'm illustrating them here. I actually didn't put it on the table sheet, but I'm illustrating it here. And it's something that we borrow from chemistry, okay? So the general equation in chemistry is C1V1 equals C2V2. And what this tells us, the ones, I don't know if you guys can see it. Here, that's as big as I can make it. So the ones stand for the initial conditions, and the two stand for final conditions. In other words, where we start and where we end. The C stands for concentration, and the V stands for volume. So what this equation is telling us is that the initial concentration multiplied by the initial volume should yield the final concentration at the final volume. This is the way that dilutions are done. You guys did a dry lab on this week 2 of this term, okay? So what I'm going to do is I'm going to calculate this first one so you can see that what the author is doing actually does make sense, okay? And then you can choose to calculate the rest of them if you want to. You don't have to at all. I'm just trying to explain to you how these final concentrations are being calculated, okay? So you see this first example, we'll look at C1, the initial concentration. We're starting out with 10% bleach, so the initial concentration is going to be 10% bleach. The initial volume is how much of it we're going to use. We're going to use 1 milliliter. So there it is, 1 milliliter. The final concentration, we don't know. We're trying to figure that out. And then the final volume, well, we started with 1 milliliter. Then we added 9 milliliters for a final volume of 10 milliliters. So our final volume is 10 milliliters. So if we know all this, then what's the final concentration? Hopefully your algebra skills are sufficiently advanced to know that to find C2, we divide both sides of this equation by V2, okay? So therefore, C2 is C1V1 divided by V2. Here it is, okay? What's concentration 1? Well, concentration 1 is 10% bleach. What's the initial volume? The initial volume is 1 milliliter. There it is. Now we're going to divide by V2. What's V2? Well, the final volume is 10 milliliters. 10 milliliters. The milliliters cancel as units. So we have 10 divided by 10, which comes out to be 1% bleach, which is what we just made, 1% bleach. So it makes sense, right? Common sense, common sense. You take 10%, you divide it by 10, you end up with 1, okay? So here's your first Petri dish, okay? So in the first Petri dish, you're going to add 1 milliliter of 10% bleach. You're going to add 9 milliliters of distilled water to end up with 1 milliliter of bleach in dish 1. Now what? Well, you're going to take that pipette, you're going to stir those contents so you have a good uniform solution of 1% bleach, and then you're going to use this 1% from the first Petri dish. That's why these two are in yellow, because they're from the same Petri dish. You're going to use that 1% from the first Petri dish, and you're going to put 1 milliliter into the second Petri dish. They're going to add 9 milliliters of water for a final volume of 10 milliliters. That way you'll end up with 0.1 milliliters of bleach. Excuse me, let me just say that again. That way you end up with 0.1% bleach in dish number 2. Okay? Then you're going to take 1 milliliter from dish number 2 and put it into dish number 3. So here it is, 1 milliliter from dish 2 into dish 3, and we're going to add 9 milliliters of water, and then when you stir that, you're going to end up with 0.01 bleach. That's it. You got your 3 Petri dishes. Are you guys with me? So anytime that we have something that is the same, you keep the same pipette because the concentration isn't changing. Okay? So for example, here where you're adding 9 milliliters of water to this, to the first, the second, and the third Petri dish, if you keep that pipette clean, you should be able to use the same pipette in all 3 dishes as long as you don't get it wet with a solution from the dish, okay? So you got 9, 9, 9. You can use the same pipette for it. There it is. We have our 3 bleaches. Now we're going to move to Lysol, okay? What comes in the kit? In the kit, we start out with 10% Lysol, okay? This is a little bit different. This is a little bit different. In the first one, they did dilutions. In the second one, what they did is they say, okay, label 3 Petri dishes, okay? We're going to label 3 Petri dishes. One is going to be 10, one is going to be 5, one is going to be 2.5. All right. Now what are we going to do? Using the same pipette, we're going to add different volumes of that initial 10% Lysol to each dish. To the first one, we're going to add 10. To the second one, we're going to add 5. And to the third one, we're going to add 2.5. Okay? Using a different pipette, okay, to the first dish, you're not going to add any water, none. To the second dish, you're going to add 5. And to the third dish, you're going to add 7.5 for a total volume of 10 mLs on each one. That's it. You're done with your Lysol. We move over to hydrogen peroxide. Here's our hydrogen peroxide. Okay? So this, again, this is why I understand if you guys are getting confused. Because on the first one, we did a dilution. On the second one, we dispensed the same initial solution to all 3 Petri dishes. And on the third one, we did a third different thing. Half of it is we're dispensing the same thing, and then we do a dilution. So the author isn't being uniform, so unless you really know what's going on, it's really easy to get lost. So I can understand if you're having problems with this, okay? So let's look at hydrogen peroxide. Not surprisingly, we're supposed to have 3 dishes. Dish 1, dish 2, dish 3. Remember, 1 is yellow, 2 is green, and 3 is blue, okay? So 3%, 0.3%, and 0.03%, okay? Now, what are we going to do? What we're going to do is that to dish 1 and 2, we're going to grab the 3% hydrogen peroxide, and we're going to add 10 and 1 milliliters to each one of those Petri dishes, okay? To the first Petri dish, we're not going to add any water, but to the second one, we're going to add 9 milliliters, and that's going to take us from 3% to 0.3%, okay? Now what? For the third dish, we're going to do a dilution. So in the third dish, we're going to take 1 milliliter from the second dish, add 9 milliliters of water, and dilute it to 0.03. Okay? So let's recap on hydrogen peroxide. Dish 1 and 2, 10 and 1 mLs. Okay? For dish 3, we're going to take 1 milliliter from dish 2, and then we're going to add 9 milliliters of water, and that's going to be dish 3. Isopropyl alcohol. This is the last one. So the isopropyl alcohol, we need 3 dishes again. We need 50%, 30%, and 10%. This one gets easier. This one's a lot like Lysol. So with the 70%, you're going to add 7 milliliters into dish 1, 4 milliliters into dish 2, and 1.5 milliliters into dish 3. Then you're going to add water. Now, because all these 3 are the same, you can use the same pipette for all 3. Then you're going to add water. You're going to add 3 to the first one for a total volume of 10 mLs. You're going to add 6 to the second one for a total volume of 10 mLs. You're going to add 8.5 to the third one for a total volume of 10 mLs. Once you have done that, you have gotten all your Petri dishes. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a 13th one which is a positive control. Okay, what's a positive control? Well, positive control means that it doesn't have any disinfectants in it. So we're going to put 10 milliliters of distilled water, and that's it. Okay. Then you're gonna grab 2 more Petri dishes. One is going to be called soak. The other one's going to be called dry. Okay. So what's going to happen, okay, is that you're going to take 13 glass beads that come in that kit. You're going to take a Petri dish. Okay, you're going to take a Petri dish. You're going to label it soak. And you're going to take your E. coli broth with the cap nice and tight. You're going to shake it. Okay, you're going to shake it. And you're going to pour that onto the soak dish. Okay, you're going to pour it in there. Then you're going to take 13 glass beads. Okay, and your author says that you're going to use tweezers and flame them. Okay, and I got to tell you, it was hard to. If I didn't know what I was doing, I would not understand what they were saying. Okay, so this is what it looks like. Let me switch cameras here. Okay, so pretend that this is the tweezers that I'm going to use for transferring my beads. Okay, what I'm going to do is I'm going to soak them in isopropyl alcohol, 70%. And what the isopropyl alcohol does is it kills all the bacteria on my tweezers. Okay, so you're going to need your little Bunsen burner. You're going to need 70% isopropyl alcohol. I put some in this Petri dish. Okay, I'm going to put my tweezers so they're well covered in the isopropyl alcohol. Okay, because the alcohol is what kills the bacteria. And now what I'm going to do is I'm going to pass this over the fire like this. Okay, and see how it catches on fire? Okay, we want that to happen because when it catches on fire, it burns away the alcohol, and now this is not only clean, it's also absent of alcohol. If I hadn't flamed it first, and I grab a bead, and that bead is supposed to have bacteria on it, it's supposed to because we're soaking them in E. coli, right? And I transfer that bead with forceps that have alcohol in it, the alcohol is going to kill the E. coli, and that's going to skew my results. So we have to, to recap, you put these guys in the isopropyl alcohol to make sure that it kills the bacteria, okay? And then be careful because the probability of making a mistake here is high, okay? And then you're going to flame it, and the flaming is going to catch the alcohol on fire, and that's going to get rid of the alcohol. So you have clean, alcohol-free instruments with which to move your beads around. Okay, that's the whole idea here. All right, I'm going to move my isopropyl alcohol. Whatever you do, ladies and gentlemen, a common mistake for whatever reason is to have this thing hot and then dip it back into the isopropyl alcohol. I have my students do that all the time. If you do that, you're going to catch this stuff on fire, and now you're going to have a fire on your table. So make sure that the instrument you're wielding is cool before you put it back into the isopropyl alcohol. Otherwise, you're going to catch that alcohol on fire. Okay? All right, let's go back to this. Let's see. It's kind of fun. I get to play with new toys all the time. Okay, so positive control makes 13 Petri dishes. I'm going to soak my 13 beads well in that one Petri dish that has E. coli in it. okay? And once it has sat there, your author doesn't give you a time, okay? That's a little bit weird. It doesn't give you a time. So let me give you a time. Let it soak in E. coli for about a good 10 minutes, okay? Once that has happened, use your newly cleaned tweezers to transfer from the soak Petri dish to the dry Petri dish, okay? And I had one student say, well, I can't find my filter paper. It really doesn't matter, okay? Take a kitchen towelette, toilet paper, it doesn't matter. Something that you can discard safely, okay? And what you're gonna do is in the dry Petri dish, you're gonna put a little circle of that paper on the bottom of your Petri dish, okay? And then you're gonna transfer the beads from the wet E. coli Petri dish to the Petri dish that has the paper on the bottom. If you have the filter paper, so much the better. But if you don't, any paper will do. All we're trying to do is we're allowing the E. coli that attached on the beads when they're in the soak to dry on the beads. Okay, that's all we're trying to do. There's no magic here. Okay, we're allowing that bacteria to dry on there and attach itself to the beads. So how long is it going to be in here? Let it go to dryness. Let it sit 10 minutes. Okay. Once you have done that, you're going to put one of each beads into each of the 13 Petri dishes that we just prepared. Okay. And it has to sit in those Petri dishes for 10 minutes. Now, the reason this is interesting is because it makes sense that 10%, let's try this again, that 1% bleach is probably going to kill more bacteria than 0.1, and 0.1 is going to kill more than 0.01, but we don't know by how much. That's what makes this experiment so cool, so neat. We know that 10% Lysol should be more effective than 5%, and we know that 5% should be more effective than 2.5%, but what concentration is going to kill all the bacteria? Or is there a concentration that kills all the bacteria at all? We don't know. That's what's neat. So we're going to put the beads into each one of these solutions for 10 minutes and allow the solution at this concentration to kill as many bacteria as it can. Okay. While you're waiting for those 10 minutes, you're going to grab 13 nutrient broth plates, and your instructions tell you to use the original container because there's nothing else in there that can hold 13 nutrient broth dishes, okay? So you're gonna have to use the original container in order to keep them all upright. And while you're waiting these 10 minutes, label the 13 nutrient broth tubes with each one of these, okay? So you're gonna have one that's gonna say 1% bleach, 0.1% bleach, 0.01% bleach, 10% Lysol, 5% Lysol, 2.5% Lysol, and so on, all the way down to the positive control, okay? So you should have 13 nutrient broths. Once that has happened, again, you can go through that weird little flame thing where you're going to soak your forceps in 70% isopropyl alcohol, flame it to get the alcohol off, and you're gonna transfer one bead from that plate to its respective nutrient broth tube. And you can do that with all 13 plates, okay? So one bead from each Petri dish to one nutrient broth tube that is labeled identically. You're gonna set it and allow it to incubate for 48 hours, 2 days. So if you do it today, okay, you have Sunday, Monday. By Monday or Tuesday at the latest, you should have results. Okay? I feel like I'm forgetting to tell you something. I don't know what it is. It must be important because it's bothering me. Oh, I know what it is. Do not throw away your E. coli yet. As I've told you guys many times, don't get rid of material until you know that the experiment is over. So the Petri dishes that you have just used, feel free to discard those in the proper manner by soaking them in 70% isopropyl alcohol and discarding them. But the soak E. coli, if there's a way for you to return that to his test tube without gripping it on yourself, doing it carefully, and capping that just a little bit longer, please do so. Okay, don't throw this away yet, because we may. I'm trying to give you guys an extra credit assignment in case you need it, and I don't remember if the extra credit assignment uses E. coli or not. So my point is don't get rid of that E. coli. All right, carefully decant it back into that test tube, and let's use it for the extra credit assignment. Okay, so I hope this helped. I'm deducing that this is where the problem is at, and like I said, I uploaded these tables to the lab in order to guide you as to how much of each substance needs to go into each Petri dish. Okay, so I hope that helps. Have yourselves a wonderful day, and I'll probably be here tomorrow. I don't have a life. I'll be here on Sunday, so if you guys still have questions, go ahead and email me. I'll probably respond to it tomorrow. Okay? Have a wonderful evening.